Hi, I'm going to keep reading from Our Mysterious Universe. Star facts. Of all the stars, we know the sun best because it is the closest star to Earth. Thousands of years ago, people recognized that the sun made life on Earth possible. Galileo was one of the first who studied the sun in detail. Using his telescope, he observed sunspots or dark patches on the sun's surface at the beginning of the 17th century. Since Galileo's time, more information has been gathered about the sun. Using such tools as powerful telescopes, spectrographs, devices that break down light into the colors of the spectrum, and electronic cameras, we know that energy travels outward from the sun's core and leaves the surface or photosphere on its way to space. The sun is nearly 93 million miles from Earth. Although it appears to be calm and still, it is actually a churning mass of bubbling gas. It is constantly sending super hot material into space. The sun's core is dense and extraordinarily hot, more than 15 million degrees Kelvin, about 29 million degrees Fahrenheit. At that temperature, hydrogen atoms join together or fuse to form helium atoms, releasing tremendous amounts of energy. This process is called nuclear fusion. The energy produced by nuclear fusion takes thousands of years to reach the sun's surface. Then that energy is released. Some of it reaches Earth 8 minutes later as photons of ultraviolet, infrared, and invisible light, also called sunlight. On page 14, at the top, under the picture of the sun, it says sunspots were the first indication that our sun is not a uniform ball of fire. On the bottom of page 14, we have a diagram showing the layers of the sun. We have the nuclear reactions produce energy in the core. Energy travels through the radiative zone as tiny particles called photons. In the connective zone, energy is carried by currents of hot gas. The sun's visible surface is called the photosphere, and beyond the photosphere is the chromosphere, the first layer of the sun's atmosphere. On page 15 at the top, we see a picture that has a caption, "A massive explosion known as a solar flare occurs when energy has built up in the sun's atmosphere is suddenly released." And the caption to the picture on the bottom, "The outer part of the solar atmosphere is the corona. It can be seen as a milky white crown when the moon passes in front of the sun during a total solar eclipse." The life cycle of stars. The sun isn't the biggest star or the oldest. Studying the sun has helped us learn much about other stars. By observing different stars at different stages in their development, we can learn how they form and how they change over time. Stars form in a nebula, a giant cloud of gas and dust. Over millions of years, the gas and dust come together in clumps of matter called protostars. Gravity works inside each protostar, making the matter more densely packed. Once the core of a protostar becomes hot and dense enough, nuclear fusion begins and the star shines. The mass of a star, the amount of matter it contains, determines its future. The greater the mass, the brighter and hotter the star will be. Massive stars, however, use up their hydrogen, the fuel needed for nuclear fusion, more quickly than less massive ones. When a star the size of our sun stops fusing hydrogen into helium, its core begins to collapse under the force of gravity. As it collapses, the core heats up drastically. Nuclear fusion causes the star to swell, sometimes to more than 100 times its original size. Once this expansion has cooled its surface, the star is called a red giant. Eventually, nuclear fission stops and the star's outer shell blows away and creates a cloud of dust and gas. The remaining core is very hot and dense and is called a white dwarf. The white dwarf will eventually cool and become dark. Above the picture on page 16, the caption says, Astronomers observe nebulae to learn about star formation. Shown here is a horsehead nebula in the constellation of Orion. Kind of does look like a horsehead. The life of a star diagram at the top of page 17 says first, number 1, a star like the sun shines for billions of years during its main sequence lifetime. Number 2, at the end of its main sequence lifetime, the star swells into a red giant. And number 3, outer layers are blown away and the core, a white dwarf, cools and eventually becomes dark. Check out the black text box. How heavy are the stars? The mass of a star is usually measured in relation to our sun. The mass of our sun is about 333,000 times that of Earth. Stars can be from 1/10 the mass of our sun up to as heavy as 100 suns. Stars with too little mass for nuclear fusion to begin are called brown dwarfs. There you have the sun. And then you have a red giant has about the same mass as the sun. A star more than 8 times the mass of our sun doesn't end as a red giant. Its core is so dense and hot that heavier elements such as helium, carbon, and oxygen fuse to produce still more energy. When the massive star finally collapses, its core forms a very dense neutron star. Its outer layers explode into space, producing a supernova that shines brilliantly for a short time and then fades away. The dust and gases thrown into space by a supernova are full of heavier elements such as iron, silver, and gold. These elements can mix with hydrogen and form new stars and planetary systems. Our sun, the planets in our solar system, and all living things on Earth come from the remnants of at least one supernova. So we could say that our planet is made of stardust. A supernova leaves an extremely dense neutron star that may rotate so fast that it sends out pulses of radiation. Then it is called a pulsar. Sometimes, however, a supernova does not leave behind a neutron star. Rather, an object so dense that not even light can escape its gravity is left behind. This object is called a black hole. Black holes can't be seen, but their effects on nearby stars can be observed. If a black hole is near another star, for example, its gravity can pull the glowing gases from the star into the hole. The gases then become so hot that X-rays are given off. The caption under the oval-shaped picture on page 18 says, "The Crab Nebula is the remnant of a supernova explosion seen in 1054. At the center of the nebula, there is a neutron star." I can kind of see it right there, I think. The caption under the diagram, "The Death of a Massive Star," says, number 1, a star about 8 or more times the mass of the sun shines for millions of years. Number 2, near the end of its life, it swells into a red supergiant. Number 3, when this star collapses, it explodes as a supernova. Number 4, the core then forms a neutron star or perhaps a black hole. You can see at the top, it could be a neutron star, or at the bottom, it could be a black hole. The diagram at the top of page 819 says a black hole's effect on a nearby star. A swirling disk of gas surrounds the black hole. Hot gas gives off X-rays, wavy lines on diagram, as it is drawn into the black hole. Streams of gas are pulled off a nearby star by the black hole. The black text box titled "Locating Black Holes" says, since no light can escape a black hole, nobody has ever observed one. Scientists can, however, deduct the existence of black holes and observe the effects of their surroundings. Sometimes astronomers can see a star moving along in orbit but can't see the object it's orbiting. That object may be a black hole. A black hole may create mirages. When a black hole passes in front of a star, gravity from the black hole bends the light coming from the star. To a viewer watching the star through a telescope, the star then seems brighter than it really is. The black hole's gravity can also make one background star look like two. Double stars and clusters. Our sun is a middle aged star. Scientists believe it will last another 5 billion years or so before it begins to expand into a red giant. Our sun is also a solitary star. Many stars, however, have a companion. These pairs are called double stars. Stars are not evenly spaced throughout space. They are often observed in clusters. There are two types of clusters, open and globular. The open clusters lose groups of a few dozen. The open clusters are loose groups of a few dozen to a few thousand stars. Over time, open clusters break up as the stars drift apart. Globular clusters are bigger and brighter than open clusters. They may contain more than 1 million stars because they are among the oldest objects known. Astronomers study them to help determine the age of the universe. The oldest known globular cluster are billions of years old. Even though stars are far away, astronomers know much about them. A star's color and brightness can help indicate its temperature and size. Astronomers classify stars into 7 types according to their color. Blue stars are the hottest, followed by white. Cooler stars look yellow, orange, and red. Scientists find out more information, such as the star's chemical composition, by dividing the light coming from the star into a rainbow of color spectrum. Scientists use a spectrometer or a spectrograph to do this. On page 20, the caption above the oval picture says, "The Pleiades is the best known open cluster. It contains about 100 stars." The caption below the oval picture on page 21 states, "The globular cluster, M80, contains hundreds of thousands of stars. It is 28,000 light years from Earth." The black text box says, "Measuring space." What units are used to measure the vast distance of space? One measure is the astronomical unit, AU. 1 AU is the distance from the Sun to Earth, or approximately 93 million miles. Another unit of measure is the light year. 1 light year is the distance light can travel in 1 year. Light travels about 186,000 miles per second, so 1 light year is about 6 trillion miles. That's 6 trillion miles. And then down at the bottom, there's a diagram that shows the type of stars. There's type O, type B, type A, type F, type G. The sun is a type G star, type K, and type M. You can see the different temperatures there. Galaxies. Almost all of the stars we see in the night sky are part of one galaxy, known as the Milky Way. Until the 1920s, astronomers disagreed about whether the Milky Way was the entire universe or if other galaxies existed. The data available then could be used to back up their hypotheses. Edwin Hubble, an American astronomer, used the most powerful telescope of his time to gather data about the Andromeda Nebula. He discovered it was too far away to be part of the Milky Way. This meant that the universe extended beyond our galaxy. Within a few years, astronomers recognized that the universe was made up of many galaxies, including the Andromeda Galaxy. Categorizing galaxies. A galaxy is an enormous collection of stars, dust, gases, and planets. Scientists categorize galaxies for the same reason they categorize stars and planets. If we can find out how galaxies are alike and different, we can better understand how galaxies work and how they form. One way to categorize galaxies is by shape: elliptical, spiral, barred spiral, and irregular. Elliptical galaxies are shaped like a ball or an egg. These galaxies may be large or small. They contain mostly old, red stars and a little dust and gas. Spiral galaxies, like our own Milky Way, are shaped like disks. Spiral galaxies bulge in the middle and have luminous spiral arms. They usually contain plenty of gases to form new stars. Barred spiral galaxies resemble spiral galaxies, but they have straight bars of stars across the middle with arms curling out of each end. Scientists believe that new stars are born in the bars of these galaxies. Irregular galaxies have no set shape and are rich in gas and dust. They are usually the smallest galaxies with many young stars and bright gas clouds where stars are forming. The caption under the picture on page 22 says the Andromeda Galaxy is the farthest point in the universe visible to the unaided human eye. The text box on page 22 says the Hubble Telescope. High above Earth's surface is the Hubble Space Telescope. This unstaffed observatory, named after Edwin Hubble, was launched in 1990. The telescope is powered by solar panels and uses radio antenna to communicate with astronomers on Earth. The Hubble Space Telescope photographs objects near the edge of the visible universe, including distant galaxies containing billions of stars. And then on page 23, we have all of the different shapes to categorize galaxies. The elliptical shape is almost an oval. The spiral galaxy looks like a spiral. The barred spiral galaxy looks like a spiral galaxy with a bar in the middle. And an irregular galaxy is any kind of shape. The caption says, gravity holds all galaxies together, but the shape of a galaxy depends on how fast it rotates and the rate at which stars form within it. Two galaxies near the Milky Way are the large Magellanic Cloud and the small Magellanic Cloud, are irregular galaxies. They orbit the Milky Way, taking more than 1 billion years to travel once around it. Gravity holds these two galaxies in place, but it's also working to pull apart the small Magellanic Cloud. Eventually, the smaller galaxy stars will probably be pulled into our own Milky Way. The Magellanic clouds are visible only from the southern hemispheres. We can't see them here because we're in the northern hemisphere. Groups of galaxies. Gravity keeps galaxies together in groups and clusters. These clusters also form bigger groups called superclusters. At present, astronomers have identified more than 50 superclusters. Each one contains thousands of galaxies, spreading over distances that would take a beam of light tens of millions of years to cross. The Milky Way, the Andromeda Galaxy, and the fewer smaller galaxies, including the Magellanic Clouds, form what is known as the local group. How close together are members of our local group? The Andromeda Galaxy is about 2.25 million light years from the Milky Way. The Magellanic Clouds are much closer, just about 200,000 light years away. On page 24 at the top, the caption to that picture says, the peanut-shaped small Magellanic Cloud contains about 2,000 star clusters. The caption to the picture on the bottom of page 24 says, the Virgo cluster is 50 million light years away and contains more than 2,000 galaxies. And the caption to the circular picture on page 25 says, the irregular galaxy NGC 6822 is one of the galaxies that make up the local group. It is 1.75 million light years away. Galactic surprises. Scientists use many different tools, including radio and infrared telescopes, to explore the Milky Way. Near the center of our galaxy, scientists have found extreme temperatures, star motions, and disturbances. These discoveries have led astronomers to believe there must be a black hole in the core of the Milky Way that is 2.5 million times more massive than the Sun. Some distant galaxies, called active galaxies, also seem to give off more energy than expected. The most powerful kind of active galaxy is called a quasar. First discovered in 1963, quasars seem to be quite small and far away, but emit huge quantities of energy. Scientists now believe they are the cores of galaxies many billions of light years from Earth. The cores may have giant black holes that are absorbing huge quantities of matter, which could explain why so much energy is being released. And I'm going to stop there. We'll continue the Big Bang and other mysteries next time.